let's start with the problems on vectors. Before starting with the problems, I want all of you to go through these time saving results, TSR. In short, it is called as time saving result. Because these time saving results will definitely help us to solve the problems quickly. What is most important in the entrance examination is how you manage the time. You can't be just working out all the steps. So wherever there are some time saving techniques are available, we shall make use of them. Now here are a few, and some more I will just give as and when it comes. The first simple technique says that the ratio in which the point P x, y, z divides the join of x1, y1, z1 and x2, y2, z2. What is this? Let's take a straight line which is the join of the points A and B, where A is given by the points x1, y1, z1 and B is the point x2, y2, z2. Now P is another point. Let's say P is some point whose coordinate is x, y, z, and it is dividing the line joining AB in the ratio L is to M. Then this ratio L by M is simply given as the ratio of x minus x1 by x2 minus x. It is x minus x1 by x2 minus x. Or you can also take this ratio to be equal to y minus y1 by y2 minus y, or you can also take as z minus z1 divided by z2 minus z, and you note that the points APB are collinear. APB, AP and B are collinear. So whenever 3 points are collinear, and if you know the coordinates of the ends of the line joining the 3 points, and the third point which divides line in any specific given ratio, then the ratio is immediately can be written like L by M equals x minus x1 by x2 minus x. Now here we have a problem from the exam. The ratio in which the point whose position vector is I plus 2j plus 3k divides the join of the points whose position vectors are minus 2i plus 3j plus 5k and 7i minus k is answers A minus 3 is to 2, B the ratio is 1 is to 2, C the ratio is 2 is to 3, and D the ratio is 4 is to minus 4 is to 3. Okay, it's very clear that the ratio in which the point whose position vector is I plus 2j plus 3k is going to divide. So I can take x by z as the point 1, 2, 3, and it is dividing the join of the points whose position vectors are minus 2, 3, 5 happens to be our x1, y1, z1, minus 2, 3, 5, and x2, y2, z2 is the point 7. As there is no j point here, the middle point is 0 and the coefficient of k is minus 1. So the position vector of the point D becomes, which is x2, y2, z2 is 7, 0, minus 1. So now you can instantly write down the ratio. The required ratio is L by M. What is the value of x? X is 1 minus x1. The value of x1 is minus 2. So 1 minus of minus 2 divided by x2 minus x. The value of x2 is 7 minus x. The value of x is 1. So this is 1 minus of minus 2, that is 1 plus 2 divided by 6. 1 plus 2 is 3 by 6. So 1 by 2. So the ratio is clearly, it is 1 is to 2 and the answer is D. So what did we notice in this point? We noticed that if you know the position vector of a point which divides the line joining two given points, you write down the points as x1, y1, z1, that is the point coordinate of the point A. Write down the coordinate of the point x2, y2, z2, and x, y, z is the coordinates of the point which is going to divide the given line in the ratio L is to M. Then L by M can be determined as x minus x1 by x2 minus x, or even you can try with y minus y1 and y2 minus y, you get the same answer. So here we have learned how to use the time saving result to find the ratio of the line which is divided by a given point when the position vectors are known, and of course the points A, B, B are collinear. Okay.